So thank you, everyone. This is our day 3 Pacific poster pop session. And so we have just a few posters on the schedule. So we will move through those, have some discussion, and after that, we will have the science fiction social hour. And so I'm just checking once more to see if Ashani is here. No, Ashani. Okay, well, then I'm going to start first with my poster. And so my poster, I just had kind of, a fun idea. Obviously, I was busy planning this meeting and I didn't want to just rehash one of the papers I had published already. So I was thinking about a tool I learned from George, which is you come up with sort of two axes of factors that affect a problem, and then you look at the contrasting dimensions of that. And I applied this to SETI to think about, the search space for SETI and also implications for the Fermi paradox. Okay, that's very general. So I started specifically with this analogy in SETI that we hear a lot of the man searching under a streetlight for his lost keys. And now I decided to do a little digging. Like, where did this story come from? Now, Wikipedia says this story is very old. At least that the motif is very old, of looking somewhere that's easy to look for instead of where it might be. But the idea of the drunkard search, as it's called, is from Abraham Kaplan. He says there's a story of a drunkard searching under a street lamp for his house key, which he had dropped some distance away. Asked why he didn't look where he dropped it, he replied, "It's lighter here." Okay, so that's 1964. The reason I read that is because I was just curious, like, well, okay, how long has this idea been in SETI? How long have people been saying this? I mean, so at least since 1960, or, 1964 is the oldest, presumably, that you would call it the drunkard search. I mean, maybe the name was around before Kaplan wrote that, but at least that's when it was in print. So I did find, I've got a copy of this book here, Communication with Extraterrestrial Intelligence. This was a meeting convened in 1971 in Armenia, the Soviet American International Gathering. And so I did find some references in here to that were fun. So that 1971, that's less than 10 years, so maybe people were talking about this before. If you find a reference older than this in SETI, let me know. But Francis Crick says, if you want to approach the problem of the steps of evolution, in a useful direction, rather than from the point of view of the man looking where the light is, then you have to look at the steps that took a long time. So there, Francis Crick mentions it. And then Leslie Orgel replies and says, like, well, okay, so, Minsky says that if we adopt Francis Crick's view, then what do we do? And Francis Crick replies, well, you can only look where the light is. It's no good looking elsewhere. But Carl Sagan in return replied that you really do have alternative strategies. And so, yeah, there's just a little history for you that I thought was kind of fun. And so, yeah, if you know of an older reference, go. So anyway, that's all to say. We start with this analogy. You look where the light is. The first dimension is the spatial domain. Are the keys in the domain under the lamp or not? Yes or no? If they are, great. That's a good search. If they're not, it's a poor search. You have to go find a new light, go somewhere else, and then you'll find the keys. Okay. But the other dimension I add to this is, well, is he even going to recognize his keys if he finds them? Right? Maybe they're covered in leaves or something. There's a lot of reasons you might not find them, especially if he's a drunkard, right? So maybe they're in the spatial domain, but they're unrecognizable. Well, find a metal detector. Now you sweep your area, you find them, but you needed to enhance your search capability with a new tool. But then if they're not in your spatial domain and not recognizable, you probably just sit under the street light and wait for someone to bring the keys to you because you can't find them anywhere, right? So I think about the application to SETI then, right? The first one is you think about you think about exploration, right? So if the technosignatures is in our spatial domain and we could recognize it, just keep exploring. We're going to find it someday. It's there. But if it's not in our spatial domain, we have to expand. We have to go beyond our current ability, go find them out there. If it's in our spatial domain but unrecognizable, we have to evolve, or at least increase our sensing capabilities. Look for different modalities. And then if it's neither in our spatial domain nor recognizable, then we just exist. It's just existence is all there is. We just wait, hope that someone finds us. And so for the Fermi paradox, the first quadrant exploration, that means they are here. We have extraterrestrials here. We just have to keep looking. We're going to find them, and we're doing it the right way, or we have the tools. But the second one, expansion, means they're out there. They're not here. They're out there. We have to go, expand and to look for them, somewhere beyond here. And then, the third one, evolve, is like, well, okay, they are here, but we just don't have any way of recognizing that. We have to develop some new, completely different way of looking. And then the last one, existence, is they're not here, they're out there. We have no way of finding them, and that's kind of puts a damper on the story. But that's also one of the solutions to the Fermi paradox. So that is what I have for my poster. It was kind of fun to put together and dig through a little bit of the history. So we'll just do questions since there's only three of us. If anybody has any questions or comments, feel free. But otherwise, is Ashani on? Yeah, I think yes.
Yeah,
okay.
Ashani's here.
All right. So Ashani, I don't see any questions for me. So feel free to unmute, and you can turn on your video if you want and tell us a little bit about your poster.
Hi, my name is Ishani, and my poster is about transit-based technosignatures. Specifically, I work with Ranger, who gave a talk on Monday on working on testing an artificiality method for transit-based technosignatures called transit information density, or TID, which calculates the number of planets necessary in order to naturally produce a sequence of transits. And this would make it useful for multi-transit signals like the random transitor. And so the aim of my project was to create, run, and analyze a test for the TID metric by encoding a message as transits within a light curve and then running TID on the encoded message. It's important for the signal to be aperiodic, so as to not be confused with natural periodic objects like planets, but also structured so that it's distinct from other signals and then shows intentional pattern. So when we were brainstorming things that could be possible signals, we thought of aperiodic mathematical sequences and text passages, and those fulfill both criteria. What we ended up going with is a chosen linguistic signal as like a tongue twister, 36 combinatorically constructed variations of the English language tongue twister, she sells seashells. And the choice of taking like a tongue twister and then getting like combinatoric variations of it is that shows mathematical understanding of combinatorics and aperiodicity through its being a linguistic message, and also structure because twisters are so repetitive. They also have a clear rhythm, and they're used in many human cultures to help teach children language, which was like a nice philosophical thing to think about. And we chose that one in particular because it's a short phrase with a limited number of repeated sounds, only 4. So it results in a simple grammatical structure that we use to encode the message. It has the sounds sh, s, e, and l's, and then they repeat in sort of like a sh and sa, or like consonant sounds, and e and l's are like vowel sounds, and they repeat one after the other 4 times. So we use that structure and the total number of sounds in order to combinatorically encode the message. We used that and a binary encoding for each sound in order to create a longer list of binarily encoded sound chunks. And then we turned those into transits in order to create an artificial light curve, which we analyzed via standard metrics like the Lumskarkel and Boxley squares periodograms, as well as the TID metric. And what we saw in the results were that the structure and the periodicity were distinct in the results of both. They were all consistent with each other. We saw multiple different periods if you're on the periodograms, specifically at length corresponding to the length of a word in a sound chunk in our encoding scheme. And the number that we got for our TID metric was closer to random. It still fell within our random range, but it was not appearing as periodic. It was consistent with the other results. And that's all I have.
No, thank you. That's really interesting. So, any questions or comments? Feel free type it in. So, no, I have one. I saw Rangers talk, obviously, and um, also, comment and a question. So the comment it made me think of is when I was in graduate school, Sean Domingo Goldman and I were at I think astrobiology conference, and we came up with this idea that I think made it into a conference abstract at some point later, which was using the moon as a broadband omnidirectional technosignature. And it reminded me of this idea. We weren't necessarily thinking about transits, but this was well before even the Kepler mission. But the idea was that you could, take some, mirrors on a bevel that flip back and forth, the solar panels on the other side, and you could make it blink and send messages. And we were just thinking about like an alternative to a radio SETI beacon. And so then I saw, Ranger talk in your poster, and I thought, well, that's very interesting because it's actually the same idea, but then you're actually putting it, going several steps further, where you're saying how much information could you encode, and then specifically in the transit. So that's just what it reminded me of. My question is, did you think much about what the mechanism would be? Like I just said, okay, we said a moon with, blinking mirrors on it. I think Ranger maybe mentioned a star shade. Have you thought about the different mechanisms? And the reason I ask is because this seems like it would be the perfect kind of idea for the sort of long-lived beacon that people have talked about in SETI, where maybe the civilization goes extinct, but you have robots tending a beacon to keep a message going to say we were here, or something like that, or whatever reason, a low-cost beacon that would be easily discoverable, maybe not a high information content message, but an SOS or a she sells seashells or something like that, right? So did you think much about that and what would be a good long-lived way to maintain that kind of message?
Um, when we were discussing it, we were talking about having multiple transit depths. It would have to be something that can do like 3 different depths. Um, so something that would unfurl. We were thinking something like how JWST sort of like just unfurled, something like that. But in terms of much of the mechanics, we didn't discuss that very much.
Yeah, no, that's okay. It's just something to think about. Um, Graham has a comment if it could be something transiting with a periodic signal, but then hiding inside something that some kind of area periodicity, intentional world-sized transit with regular period, but has some kind of surface up. Yeah, I mean, it's fun to think about. I mean, this is a good segue into sci-fi, to be honest, because you start imagining these kinds of things. But and then uh, well, I think we can move on to Andrew. The other thought I had was I have a lot of exoplanet colleagues who would just, the data reduction nightmare of just trying to find carbon dioxide and TRAPPIST, any of the TRAPPIST planets is pulling out your hair. So trying to find information in the signal, but no, I mean, it's really cool work. So thank you for sharing that. Okay, Andrew, you are up.
All right. Well, hello, everyone. This previous discussion set me up beautifully because it sure already sounds like we're talking about science fiction. So I'm Andrew Fracknoy. I'm a retired astronomer and college instructor for many years. I have the privilege of writing an astronomy textbook with David Morrison and Sidney Wolfe, which is now free online. And I'm on the board of the SETI Institute, where I'm constantly hearing about new ideas in the SETI field. And my interest for many years has been science fiction and how it interacts with the popular understanding of science. There's, of course, a lot of awful science fiction out there, alien monsters invading, spaceships traveling at impossible speeds, things that have no relationships to actual science. But in amongst that, there's quite a bit of science fiction, particularly written by people with some scientific training, which takes off from the latest ideas in science or extrapolates some known idea in science and then takes a look at how it affects human characters. And for many years, I've been keeping a web page all about science fiction that is reasonable, that's based on reasonable science. And for this conference, I thought I would take just the SETI-related parts of that very long web page and create a separate document. So I have done that. Let me see. I'm going to put that into the chat. I don't know if that worked. Let's see. My chat went away. Let's see. Let's try it again. Yes, there we go. So that's where you can find the document that has an annotated guide to science fiction about SETI that's based on some reasonable ideas, extrapolating reasonable ideas. And there's a long history of that we know goes back to Frank Drake's experiment in 1960, which then caused the science writer of the New York Times, Walter Sullivan, to write a popular book called We Are Not Alone later in the 1960s, which was a big hit and very influential. And a science fiction writer by the name of James Gunn reported that he'd read that book, and that led him to a series of short stories, which was collected in the novelization called The Listeners. And James Gunn's The Listeners was perhaps the first serious SETI-based science fiction novel, but there have been many others since then. In my poster paper, I review some of my favorite stories and novels in this direction. And as I say, all of them can be seen in my guide. Now, I'll just close out by saying that for many years, I'd been keeping a notebook of science fiction ideas as I went to science conferences or to board meetings at the SETI Institute. I'd jot something down, and I thought to myself, if I ever retire, I'm going to try my own hand at science fiction writing. And I did. I retired in 2017 and joined a writers group. And at first, I acquired the most beautiful bulletin board of rejections from the best science fiction magazines around the world. But now 11 of my stories have been published. The 12th one is coming out in 2 weeks. And so I've taken the liberty of including some of my own stories, excuse me, about SETI in this list. They're all free on the web, and I invite you to take a look at them. And if you come to our social hour, which is coming up on science fiction, we'll talk a little bit more about my science fiction ideas and others, and really welcome everyone jumping in with their own thoughts and their own favorites. So that's a quick summary of my poster paper.
All right, thank you. And we do have actually one comment or question from Joe for Ashani. So the transit method only applies for a certain orbital phase, right? So only orbital or observers at certain locations relative to the star would see the message. So yeah, I guess if you're constructing that, you must have a specific set of a specific audience in mind. You know, you're in the Earth's transit zone or something.
Yeah.
No.